Following on from the previous video, we saw that when given any function f of x, say f of x here, then the inverse function here will be the reflection along the y equals x line, and if you take any point on the original function, so here it will be 2 5, and then this point gets reflected to 5 2, and we found that if you know the gradient at this point here, then you will immediately know the gradient at this point here, because you would just take the reciprocal, and then it will automatically give you the gradient. Once you know the gradient at this point here, then you will automatically know the equation of the tangent line, because you in effect have a gradient at a point, and then you know the coordinates at that point. So you should be able to work out the gradient. You should be able to work out the equation of this line here. Okay. Once you've got this equation here, well, theoretically you can also work out the line that is perpendicular to your tangent line. Now this perpendicular line here is called the normal line. Okay, so it's at 90 degrees to your tangent line, 90 degrees, 90 degrees, and 90 degrees here. The thing, so just to summarize, once you know the gradient here, then you take the reciprocal to get the gradient here. But then there's a technique that you use in order to work out the gradient of this perpendicular line here, the normal line. Okay, so let's look at any straight line. Here's a weird thing. Okay, if you look at any straight line, let's say just look at the line itself. Let's say this line here is one across. Okay, so the height here will be from here to here, which is 1 2 3 4 5. The height here is 5. The cross here is 1. But here's a weird thing. So at the moment the gradient here is 5 over 1. Now if you draw a line with a gradient of the reciprocal of this, 1 over 5, but then have it going downhill, so the negative version of the reciprocal, then this new line here will be at 90 degrees. It will be perpendicular to your original line. So for example, at the moment it is 5. The height here is 5 5 1. Okay, so now if you draw a line that is 1 5 but negative 1 5, so wait, 1 5, it will mean the up and down here is 1. So let's just look at this one here. The up and down here is 1. The across is 5. 1 2 3 4 5. So it's here. And remember, so the blue line, the gradient of the blue line here is 5 over 1. So we want 1 over 5, but then stick a negative in front of it. So that will mean here the height here is 1. The across here is 5, but we want the negative version. So this line here, you see, if you look at the blue line, which is this line here, and the new line we just drawn here, they are really perpendicular to each other. Can you see that? 90 degrees here, 90 degrees here, 90 degrees. Yeah, okay, let's look at another one here. Let's look at this red line here. This red line here is hang on, this red line here. No, let's choose a different line. Hang on. Let's look at this this blue line here. So let's say 2 up, okay, and 2 4 6, 6 across. So 6 across here. So looking at the blue line, it is the gradient is 2 over 6. Okay, 2 over 6. So this line here, the blue line here, has a gradient of 2 over 6. Okay, let's not simplify it. So now if you draw a line of 6 over 2, but the negative version, then the new line will be perpendicular to the blue line. So hang on. So you want the up and down of 6, the across of 2. The up and down of 6. Let's just say 2 4 6 here. The up and down of 6. The across of 2 1 2. Don't forget, we want it going downhill. So it has to be from here to here. So let's just draw a straight line here. Okay, you see the blue line here. Now it is perpendicular to the blue line, and it doesn't matter what gradient you choose. Hang on. So let me show you some more examples. Wait there. So let's choose a gradient of, let's say, hang on, let's say this gradient of hang on, why doesn't my pen work? Okay, let's say this point here. Okay, 3, 1, 2, 3 here. Okay, and then 2 up. So from here to here. So here the up and down here is 2. Okay, and the across here is 3. Now if you draw, so at the moment the gradient is 2 over 3. Now if you draw a line with a gradient of 3 over 2, but negative version, then it would be perpendicular to this. So watch this, hang on. So I'm going to draw another line of this gradient here. So the up and down will be 3. So from here to here, and then the across is 2. I'm just going to choose this one here, from here to here. Hang on, from here to here. So this line here has a gradient of the up and down here is 3, the across here is 2, and it's going downhill. But look at this, if I move it across, it will be perpendicular. Hang on, let me just erase this. It will be perpendicular, see? See, it's pretty much, and it will work for any gradient you choose. Let's say 5 across. Hang on, 5 across, 2, 4, 5 here, and then 2 up here. Okay, so this line here, and this line here will be from here to here. So this here has a gradient of what is it? Of 2 over 5. Now if you have a gradient, if you draw another line of a gradient of 5 over 2 for the negative version, so let's do that. So the up and down of 5. So the up and down of 5. So it's, well, hang on, let me think. So it will be hang on, from here 2, 4, 5 to down here. So hang on. So that'll be here and here. Okay. So this line here, by the way, has a gradient of negative 5 over 2. Now, if you move it anywhere along here, see, no matter where you move it, it's always 90 degrees. See? Okay. So the point is that once you have a gradient of let me get rid of this. So no matter where you move it, it will always be at 90 degrees. Look, see, 90 degrees, 90 degrees, 90 degrees. So once you have a gradient, if you take the negative reciprocal, if that makes sense, then you get a perpendicular line to your original line. So going back to the original, hang on. So hang on, let me think. So if you get given a hang on, yeah. So just bear that in mind. I will give you an example in the next video. Okay.